Let's solve this question. This question is taken from SPM 2022, paper 2, section A, and it is from your form 5 at math, chapter 6, trigonometric function. Now let's look at part A. We want to prove that cotangent x over 2 minus tangent x over 2 is equal to cotangent x. Let me copy down first. Cotangent x over 2 minus tangent x over 2 is equal to 2 cotangent x. So this one is actually equal to cosine x over sine x, right? Okay, if you add a 2 in front of it, it will become like this. So later on, I know that I want to make this thing become this, and then I change it to 2 cotangent x. Okay. Now this is cotangent, so this is cos over sine. Cosine x over 2 over sine x over 2 minus tangent, this is sine over cos sine x over 2 over cosine x over 2. Now I notice that now we have 2 terms, here this is 1 term. So definitely I need to combine these 2 terms together, become 1 term, right? So to combine these 2 fractions together, they need to have same denominator. So what I'm going to do next is this one I'm going to time cosine x over 2, here also time cosine x over 2. So for this part, I'm going to time sine x over 2, do the same thing for the denominator, sine x over 2. Okay, so now they will have common denominator, we can combine them together. So here you will get cosine square x over 2, here you will get sine square x over 2. Okay, so here is sine. So this is sine x over 2 times cosine x over 2, right? Okay, so here you need to know this cosine 2 theta is equal to cosine square theta minus sine square theta, right? So another formula that you need to remember is to solve this question is sine 2 theta is equal to 2 sine theta cosine theta. Okay, but now this is cosine square x over 2, sine square x over 2. We can modify this. It becomes cosine theta is equal to cosine square theta over 2 minus sine square theta over 2, right? So this one we can do the same thing. Sine theta is equal to 2 sine theta over 2 cosine theta over 2. Now, so there's one. I'm going to change the cosine theta, but here is x, so I'm going to write cosine x. But here we have a problem here. We want a 2 here, but we don't have a 2. How? It's okay. You can just simply add a 2 for it. Let me just add a 2 for it. But when after you adding a 2 for it, you want to change the value. You cannot change the value. You just can change the way of writing it. So how do I keep the value remain unchanged? So I am going to multiply this whole thing by 1 over 2. Therefore, this thing still equal to this one. Okay? Now this is cosine x. 1 over 2 I will just copy first, and this is actually equal to sine x, right? Sine x. Now, divided by 1 over 2, you will get 2 cosine x over sine x. Okay, what is this one? Okay, correct, right? So now this is cotangent. This is cotangent x. Is that correct? Let me check. 2 cotangent x. 2 cotangent. Okay. Correct. Proven. Okay, this is the answer for part A. Now let's go to part B. Hence, sketch a graph of this for x is from 0 degree until 360 degree. Okay. Now you look at this one and this one slightly different, right? So I'm going to try to use this one, what we proved just now, to move the term so that I get this. So I'm going to move the 2 cotangent x over here and just move it to another side. So cotangent x over 2 minus 2 cotangent x is equal to tangent x over 2. Now, these and these, they are exactly the same, right? So I'm going to change this, become this one. Okay, now we can start to sketch the graph. Okay, so to sketch this graph, I'm going to show you this method. I will modify the parent graph. So this is a basic graph y equal to tangent x. I'm going to modify this graph to get this graph. Now first I need the period of this graph. So to get the period, as I told you before, for sine and cosine, we take 360 degrees divided by the coefficient of x, right? So for tangent, we take 180 degrees. So 180 degrees divided by 1 over 2. Not 2, but 1 over 2. So it will become 360 degrees. Then we calculate the x scale. For sine and cosine, we divide by 4, as I told you before. But for tangent, we only divide by 2. Why? Because for one cycle, this is one cycle. So one cycle is 180 degrees. We have 2 interval. That's why we will divide it by 2. So I'm going to divide this 360 degrees by 2, not 4. Okay, this is 180 degrees. So I know that later on my x scale will be 180 degrees, then plus another 180 degrees, which is equal to 360 degrees. And the question only asks us to draw under 360 degrees. So this will be easier. 180 degrees, 360 degrees. So we can stop here. Okay, this is y. Now just refer to this parent graph. So after the first interval, you will get an asymptote, right? So do the same thing for this one. Okay, so this is asymptote. Next, just follow the pattern of this graph, of the parent graph. Go this way, go this way. Okay. But be careful, you cannot turn it back like this. You cannot do it like this. It will get closer and closer to the asymptote. But you will never touch this line. So how about this one? Here will be like this. Okay, now I'm drawing this graph actually. This is not the final answer. I'm drawing this tangent x over 2. Now, what I'm going to do next, modulus it. So this part, it will refract up. It will become like this. Okay, now no more this one. I will just erase this one. And what to do next is -1. This whole graph move one step down. Okay, so this graph become -1, right? Whole thing will move down 1 unit. So it will become like this. Okay, let me redraw this part. And don't forget to label it, and this is 0 degree. Okay, y is equal to modulus tangent x over 2 minus 1. Okay, so this is the answer for part B1. Now let's go to the last part. There is no solution obtained if y equal to m. So y equal to a constant. The line is a horizontal line, right? Parallel to the x-axis. Is sketched at the same axis in 6b1 such that m is a constant. Set the range of the value of m. Okay, we draw a horizontal line so that it will not have solution, means that no intersection point. So try to think how to draw this line. If we draw this way, let's say we draw it this way, we have 2 intersection points, right? Which is not correct. So how about if I draw it this way? There will be 2 intersection points as well, because the graph will go up, right? This graph will go up. So we know it's cannot like this. So definitely we need to draw the line below this -1. Therefore, no intersection point, no solution. So our answer will be m is less than -1. So can we write this one less than or equal to -1? Cannot, because why? If you draw it over here, that would be two solutions as well, right? One solution over here, one solution over here. So the question requests for no solution. So definitely the horizontal line that we draw must be below this -1. So this is not correct. So the range of value of m is less than -1. Okay, so just now I forgot to label the axis. This is x. Okay, this is x. Now some students might be thinking, so teachers, the graph can go up like this, right? Why not the graph go down? Can the graph go down below the -1? No, cannot. Why? Okay, let me label this one. Because you try to think, this modulus, right? Modulus, the minimum it can go is 0, right? So 0 minus 1. Here is no, it cannot be negative because it's modulus, right? So the lowest it can go for the y is -1. So it will not go below the -1. Okay, so therefore our answer will be m less than -1.